Hey, can you hear me? I think I'm live. I'm just setting up my lav mic very quickly, and also I just, yeah, figured out there's a Telegram chat where I wanted to share the fact that I have my live stream. So, very quickly posting the link to that one. Meanwhile, let me open the chat in a different window so that I have access to it. I don't know, can you hear me? Whoever's watching, I see there's one person watching. Maybe there's more people going to be watching. Um, Starting in like 2 minutes, and we'll try to make this session pretty brief. So I reserved 2 hours for it, but I think that we will be done in without a break in an hour and a half, I guess, or an hour and a half. And of course, I'll be looking forward to the questions. So if there's any specific cases that you have in mind, I'll be happy to help with these. Yeah, the topic of the lecture of the live stream is regular expressions. And I'm not going, as I said, as I wrote in the description, I'm not going to go very deep into theory like the automata, finite automata theory. I'm gonna talk more about practical applications because like lots of people are intimidated by regular expressions. They look like a beast. Oh, by the way, I could be in this big window. Why not? Yeah, Virginie, hey, can read you in the chat. By the way, Virginie, it was her idea, so she was like willing to learn more about regular expressions, and I thought, okay, it's a good topic to kick off my live stream sessions because it's like it's educational, it's helpful, it's not so hard for me to talk about. Um, Definitely not like building a doc and just mentioning it here and there. I think it needs some proper focused time to talk about this. But just give me a few minutes. I want to paste the link to this talk to a Russian speaking Coda community. I know they sometimes like to, um, yeah, they would like to learn about it. I don't know if they will be comfortable with me speaking English. As as much as it is Slav-like with Slavic accent, still some people just don't understand it. They would like to have it in Russian. Um, what's the link for the stream? Uh, Here's the link. And the full Eurovision final. Yeah, it's in a different. Today is the Eurovision final, and even though I'm not a big fan of Eurovision, of course, I'm rooting for our Ukrainian band Go A. Something new. Oh no, not that. Live stream schedule. Here it is. So yeah, I'm rooting for our team. And by the way, if you're just joining and you haven't seen this, so today I'll host. So this one is gonna be a lecture about regular expressions, and then in the evening I'll make a doc from scratch. I'll make a doc very similar to what my girlfriend helped me do, so that I could get more organized this month. So I'll try to bring that process into Coda, and yeah, I guess it's gonna be fun. Um, or not. These streams are never are never too fun. I think At some point, my girlfriend told me that I should call these streams the boring streams, because it's like learning materials only. I'm talking in a monotonous voice. It's not like it's entertainment, right? It's more like a lecture, a boring lecture. So a boring stream format sounds like something, right? Okay, I'm gonna minimize myself. A shout out to my patrons. I guess I need to update this list, because the list perhaps has changed. I see that there's a few people joining after that, but as always, if I'm doing this as a part. Well, I have, for whoever's watching me for the first time, I have a Patreon, and the reason why I have a Patreon is to motivate myself, push out more content, because it's no good if I am like a Coda expert. I do things for for private, for clients on a certain fee, but then I never share anything, or I share very little of what I learn in the process. I know there are some companies, there are some competitors who also do some work on Coda, but never actually share anything. And I'm not like that. My whole life's motto is to, well, I'm an educator at heart, so yeah. But I'm also a perfectionist, so that's the problem. I would have written a lot of articles about Coda, a lot of blog posts, but I just cannot get myself do that because they are not good enough. I start rewriting them again and again and again, and in the end I never publish them. So that's why this live streams format works best for me. I'm live, I know that there's no way back. I clicked start streaming, and I'm like, there is no going back, right? And whatever I talk about, and I cannot edit it. I cannot. Well, for instance, right now I stumbled, right? So if it were like if I were recording a tutorials video, that could be pretty much the reason why I would stop the recording, start it again, then stumble again, then start it again, and never publish in the very end. So that's why these live streams is the way for me to get out at least something in as rough form as it can be. Okay, so these are my patrons. Thank you everyone for supporting me in this endeavor. And by the way, I'm getting back to client work. I finally found myself an assistant whom I trust like myself. It's a person who's capable of taking over work from my even most important clients. So I'm very grateful for that, for the fact that there's this person who's finally interested in this. And yeah, I see a bright future now. I don't feel so burned out anymore. I'm actually doing some work myself lately. I'm happy when I'm doing it. I'm actually enjoying myself, so this few months of a break were actually very good. And still I'm trying to like box out a week or something, or maybe a few days or a day each week. I'm gonna dedicate fully to Patreon and sharing the knowledge. So yeah, in a way I see a bright future. Now the regular expressions. So regular expressions, everyone, as I said, even programmers themselves very often joke about regular expressions. This is something that's not clear. Let me maybe find. So recently I was doing this thing. Okay, is it the? No, it's not. Let me very quickly sign into my other account. So yeah, this one. Lately I was doing, and there's been a thank you, Virginie. So there was this okay, that's not perhaps the dog. This one is the dog. If you've been following my work and my live streams lately, you know I've done a series on easy events. So I was building that dog, and oh yeah. So even here, like I'm using some regular expressions to split these things. Okay, not perhaps not here, but generally it's gonna be fun, yeah, because oh well, here you have something like a regular expression, and what is this like sequence of characters? So these things always often look very intimidating for whoever's not understanding what's happening in a regular expression. So I saw a lot of people. Let's just spin up a new Codadoc. A lot of people, what I see, what they are doing, they are setting up a search. So let's say there's a some, well, in task tracker, whatever, some you have some, yeah, tasks, and the idea is that you make a text control for search, and you set up here, let's say, let's ungroup this just for, because we don't really care about that. So we don't need this. So what they do, they want to set up a search functionality. What they do very often, what they go into the community and they find this in the community is that, okay, here's the, can you, yeah, so it's search. They set up the filter like this. So they take, for instance, task, regex match. So first they try to do it like task, I don't know, starts with, ends with, or there is a way to do it with find, which is actually a right way to do it with find. What they do, they often test for regex match and search, yeah, search text. So filter for tasks that are matching our search. So if we have thumbling or something, what were the tasks again? Brainstorm, right? So yeah, it seems to work, right? So you type brainstorm or best, and it kind of works. But what they fail to understand is that if you start typing a big sentence there for a search, or you start using special characters, for instance, we want to search for Zoom that has a dot in the end, right? So they search for Zoom and place a dot in the end, or we want to find all the tasks that have a dot, right? They press a dot, for instance, and they get all the and they get all the tasks. That's why is that? Because in regular expressions, a dot has a special meaning. It's not a literally searching for a dot. So using regex match, which sometimes I see Codance suggest using it, and I see this in the community a lot. So it's not really a right way to filter the test. It's not a big problem, right? But the problem is that people use it without understanding what they are actually doing when they are doing it. And that's, well, the problem with most of things about no-code tools, about coding, when programmers take pieces of code and just copy it from Stack Overflow into their code without fully understanding what's happening. And this is the problem here as well with the regular expressions. They have very often they need to use a regular expression and they have no idea how these work. They have someone write these for them. They just copy and paste them, and if they don't act in a way that they expect, then it's a tragedy. You know, they have to go and find someone to edit the expression for them. So that's what I'm going to try fix with this lecture. So what is regular expressions generally? Regular expressions is a tool that allows you to extract or find patterns in text. So there is a text value that has some pattern, and regular expressions, the whole mechanism of matching against regular expressions, helps you solve this need to either extract some data that looks like some patterns, or split data by some patterns, or replace pieces of text that match some patterns. So regular expressions themselves are patterns, right? So like words that are 3 letters or more, or all the numbers, or all the words that end in a comma, or all the separate lines in a text. So if you want to specifically, so you have your text, you're looking at it, it has some structure to it, and you need to now get something out of the text, but you know the structure. You're using regular expressions, and regular expressions themselves are these pieces of code, which is not like code. You're not like programming anything, but you are describing this pattern using a specific syntax of how you search for things in a pattern. So the pattern is described using a regular expression syntax. One of the websites where I like showcasing this is regex 101. It's maybe not the best one, not the worst one, I don't know. It's the one that I found first, I guess. It's free to use. It has a lot of settings, and it has some really nice ways. It has a debugger. It has something like you can explore how your regular expression is doing. You can see, and it has also help on the right pane. So I often use it first to compose a regular expression if it's not very obvious to me, and only then I take it and copy it into Coda. And also it has multiple flavors of regular expressions because, well, while the concept is the same, there are some small differences between languages, between how it's implemented in, let's say, JavaScript or PHP or Java. These differences are negligible. Our stream today is for basic users and general users, so I'm not going to dive very deeply into these specifics. Coda is a web application. Most of the calculations are done in your browser, so it's using JavaScript underneath, right? So it's coded in JavaScript, so we will be using the JavaScript flavor of regular expressions. That's what Coda uses. But again, the differences are ever so slightly different, so it doesn't really matter. So yeah, let's try with something. I don't know, do you have any text that you'd like to use as our test text? If you have anything coming to mind. Also, by the way, please tell me if I'm not clipping, if the sound is okay, because I see that it's redlining here, but maybe it's fine, maybe it's not, so please confirm that the sound is okay, that you can hear me without any distortion. If you don't have any text, then let me maybe just take... Okay, I can hide this. I definitely don't care about Eurovision yet. So let's take this piece of text, for instance, because it's rather nice, right? It has some pattern to it. So it's the text from the Easy Events doc. It has I made the tab bigger. Now it doesn't fit all in here, but it's a good thing to test for. So the regular expression, it contains 2 parts. First is the pattern itself, and the second part is the flags. And the flags describe the behavior of some nuances about the behavior, whether we treat this text as multi-line or a single line, whether we search only for the first match or we search globally for a lot of match, for every match in the text, etc. We will get to this in a moment. So let's start with the very basics. So, and the very basics is you can search for like a specific word, right? So a word where you type is will find all instances where this word is used. So if you have a... Oh yeah, and one important thing is that regular expression itself is read left to right, and the test string is also evaluated left to right. So when I type I, it goes through the text from left to right, it finds the match, it tracks it as a match, right? So it remembers which characters this match is in, and then it goes forward. If I have a multi, character pattern, then it finds the first character, and then it checks whether we immediately find the second character. So if you go into, there's this thing here, I guess, there used to be, okay, it's for PHP, the debugger. So it shows us the steps, how it goes through matching. So if it didn't find the is, if it found a just my name I, it would go through this I, and not finding S, it would just discard this match altogether and move forward to find the next time it finds the I letter. So this is like the logic behind it. Again, we are on a basic stream. There is also a lot of performance things to talk about regular expressions. It's possible to build to write them in ways that will just hang your document forever, will calculate forever. That's why these debuggers, like this tool, tells you exactly how much time it took to process this match, how many matches it found, and well, so on. Found only 5, and the PHP one also found 5. It also tells you how many steps it went through. So yeah, this is like if you literally write the word, it tries to literally match a sequence of characters. And as you can see right now, it's case sensitive, so address capitalized does not match the address non-capitalized. But if you turn on the flag insensitive, then it's gonna find the match. So these things here, Unicode will match things like I think it's gonna match later. It's gonna match properly Cyrillic numbers, Greek letters, all different languages. So it's a more performance heavy way to match things. If you're just looking for some numbers or Latin characters, you should not turn this off because it will be faster not to turn this. You should not turn this on. It will not. It's going to be faster if you don't turn this on. But there's also a possibility, and I think even it tries to collate letters that are similar, like a umlauts or those diacritic symbols about different letters. So maybe that even would work. So okay. We are not turning this on for basic Latin. Yeah, so this is how this happens. Then we have this or. Oh yeah, and if your expression is like, if you put in a space, then it's gonna match every space, right? Every space character. So it's like a literal character. You put 2 spaces, it's only gonna find instances where you have 2 spaces. So two spaces. I added 2 spaces. Some characters have special meaning. So you cannot, for instance, you want to search for a dot. You cannot use a dot, as I said, because dot is actually has a meaning of matches any character. So it matches any character. If I put 3 dots in a row, it's gonna match all sequences of 3 characters. So as you can see here, it's now like in each line, it finds sequences of 3 characters, and it always starts from each line. I guess that's because we have this multi-line turned off. If we had it like single line, then a new line itself is gonna be treated like a character as well. So this is, and if we turn off the global, it only finds the first match, right? So this is the flags. This is how flags work. But again, don't worry about that too much yet. Yeah, so like a dot has a special meaning, and on the right it tells you this. So it matches any characters except for line terminators, because line terminators, we have a sequence of, well, here's a new line. You may know this from some not just regular expressions, but maybe you've seen this already. So there's also some escape characters where you type a /, and after that you can have a letter that gives you, so does it tell you? Yeah, here. A new line is / and. It's a new line. So if we want to, for instance, split text by each new line, we would use this as a pattern. And it gives us oh, here it gives us matches, but let's say if we do this with substitution, we just took a new line and substituted with a new line text like this, right? So now we have everything on a single line, but all new lines are replaced with this piece of text. The carriage return, you should not worry about that in Coda, I guess, because this is like Windows specific thing. There's another trick about carriage return, but you should not, as I said, worry about it. Tabs, which also right now are broken in Coda, so you may want to use this if you're importing a TSV file, so you may like split by tabs or something. And for the escape characters, yeah, there's also a lot of classes of characters. So like /s means match any space, but not just the space like you typed space on your keyboard, but any space that can come from a different, including a new line, by the way. So we replace every space here, and every new line is also a space, and a space that's used in like Japanese language, they use maybe a different character for a space. In some other languages, or those non-breaking spaces, thin spaces, figure spaces, they all are included in this /s. So this is like all spaces. This is how you can, for instance, replace all spaces in your, like if I don't have any substitution, just took everything and put everything together, because it replaced everything that's a space, horizontal or vertical, replaced it with nothing, and we got the text that doesn't have any space. There's also H, which is only horizontal space, or it used to be horizontal space, right? I guess it's not on the JavaScript set. Maybe it used to be in the PHP. Yeah, in the PHP set, that's one of those subtle differences. You had this H, which was like a horizontal white space, and I guess it gives you this information somewhere in here. But in JavaScript, it's not gonna match against horizontal spaces, so you don't have this, right? So that's those slight differences. So you can just forget about it. It won't work in Coda. The V, again, it's a vertical tab character, doesn't match new lines, but in PHP it matches all the vertical, all the line breaks as well. So again, these are, but you will not be using this in real situations. You will just be using a space, or you will just be using a new line or a collection of new lines. Maybe you're just willing to match wherever there's two new lines, right? You can see that, well, here it replaced every collection of two new lines in a row, which is 1, 2, but here there's 3 new lines, right? Between the questions themselves, there's 3 new lines, and you see this by mentally finding a pattern in your text. So, and well, already this pattern of putting 2 new lines in a row gives us this. We can replace it with just a space, and this gives us, for instance, a more cleaner way, a more compact way to see this data. Instead of having it like this, we can see it here like this. Each question goes on a separate line, and the answer goes after that line. And well, here it also replaced 2 new lines with a space. We just have 1 extra new line here, but it replaced this with a space as well, because, well, it replaced 2 new lines with a space, right? So maybe it's not the regular expression that you're looking for. But otherwise, yeah, you can, this is what you're using. Then another one to memorize is /w, which is a word character, which means matching everything that's a lowercase or uppercase letter or a digit from 1 to 0. And it also includes an underscore character. It doesn't include spaces between words. It doesn't include any other punctuation. It doesn't include dashes. So that's how you test for a word character, right? And then there's also, okay, but now we were just testing for like one word character. We don't really want to match just one character, right? We can like test for 2, but it also, what words are of different length, right? 3 we can put 4, but this will only catch us the words that have the length of 4 word characters, right? So for that we use quantifiers. If we want to say that we want to match at least one, or it's an optional character, we use some quantifiers. So we can say, let's match, for instance, a Paul, but the letter L is optional. We can use this quantifier, the question mark, which tells us that Paul will also match. Both Pau and Paul will match, because L is an optional letter. If we don't use that, it will only match Paul. But if we say that some letter is optional, it only applies to the letter before it, or to the element before it. So now in this case, U is optional. So we can have Paul, and that will also match, because U is optional. Then we have things like plus. Plus means take the element before and match whenever it's used at least once. So it's gonna match Paul, it's gonna match Paul, it's gonna match the whole word, whole word, because this says that take whatever's coming before L and apply it, and search for it at least, that it's used at least once. And then there's the quantifier, the asterisk, which is like combines both the question mark and the plus. It says that match wherever it's used once or many times, or not used at all. So it can be Pau, it can be Paul, it can be Paul, whatever. But well, it has to have Pau and then L at least 0 or more times. So that's the quantifier here. Now, what if you want to match, to apply this quantifier not just to the L letter, but to, for instance, the whole Paul word? Well, you use brackets. And it also has some special meaning here. And you can see that it found more matches, because right now it finds matches where the whole thing, the whole Paul word is used at least 0 times, or once, or twice. And well, every space between characters is basically a word Paul used 0 times. So that's why every space between a word, between each letter is matched. But if you look at this, you have Paul, Paul, Paul. It's gonna match the whole thing repeated. So it's just Paul, and then there's Paul, 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 because I got this in the brackets. The brackets have some special meaning as well, because they allow you to specify, to split down your regular expression, to split down your match in groups, so-called groups. So each brackets introduce a group. There's a way to prevent this, but again, if we have time, we'll get to this. And if I use plus, it's gonna match only when there's a word Paul is used once or more in a row, right? The whole group, the whole thing is used once or more. It's not gonna match where it's used 0 times, right? So now we don't have that clutter here. So these are the quantifiers. There's also a thing like match. The matching is by default greedy, which means it tries to match as much as possible. So when you are going through a regular expression, it tries to match as much as possible. So it takes Paul, 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 and only then stops. If you include a question mark after your plus or after your asterisk, it means match as little as possible. So it will match Paul, Paul, Paul. So let's say we have Paul, Paul, Paul is awesome. Yeah, the word Paul, Paul, Paul is awesome. And we want to match for Paul, mentioned at least once, and the rest of the phrase is awesome, right? So the eager matching, the greedy matching, means find a match where we have the biggest possible match. So we have the Paul, Paul, Paul is awesome. So we are looking for a text that has this, the word Paul mentioned at least once, but as many times as possible, and then is followed by the rest of our pattern, right? But if we add a question mark to it, what should happen, what should have happened actually, is that it should have just got this smallest, I guess, but it didn't. So maybe I'm mistaking this as well. It should have been a lazy match. But yeah, I guess this is still matching the whole thing because it goes from left to right. So in some certain scenarios, it would just match Paul is awesome, but I guess it's a bad example of that because yeah, it still is matching from the left. As few times as possible. Yeah, it reads from left to right. So I guess that's the maybe in regular in other flavors it would work the other way. But anyway, this is like super nuanced thing. Again, the lazy matching. You will most likely not need it because it's very performance heavy, because if it finds the match that's a smaller match, it often backtracks and it often tries multiple times against the string. So if it's eager, it just finds the match, goes forward. If it's lazy, it may go back. Anyway, let's try different things. So we have a Paul followed by Paul. If we do the lazy matching, it finds just the one, Paul, and then sees if the rest. Oh yeah, so this is the scenario, I guess. This one tries to find as many repetitions as possible, and then the letter P. This one finds the first suitable case, and if it finds that with just one repetition it now matches the pattern, it assumes it's a pattern that we were looking for. So that is the idea behind lazy and eager matching. If you're looking for everything else, not a space, you can use like not a small case S, but an uppercase S. So this says not S, not a space, not a word character. This is a word boundary, a B. It gives you everything. It matches wherever there's a start or an end of a sequence of W characters. This is not a word boundary. But again, the B you will not be using as much. Something to remember, you will be using a dot, you will be using some concrete characters, you will be using the new line a lot, you will be using a space perhaps, you will be using a word character sometimes. So that's the only things to remember here. And of course, if you don't want to match each character, but you want to match a dot specifically, you also need to escape it. / dot will give you literally a dot. Here's the dot, here's the dot. So yeah, let's hide our replacements. So yeah. Is everything clear so far? And yeah, and if you want to find a sequence of things that are like not just each like hashtag characters specifically, but you want to find every sequence where it's used at least once, you may add a plus, which means match 3 hashtags in a row, match 4 hashtags in a row, match 2 hashtags in a row, but don't match when there is no hashtags. And if you want to, and the asterisk is often useful when you want to search for a bigger pattern, but some part of it in the middle is something that may appear like once, twice, or not appear at all. So if, let's say, the name of my, then we have any word character that may or may not appear here, or well, any character. A space, then any sequence of characters, or well, we're looking for a word boundary here, then any set of characters here, then a word boundary here, and says is. The name of my event is. And this means that we have an end of the word here, so if we add something to my, it's not an end of the word anymore, so it has to follow specifically by the end of the word. So my space will not match, just my will match. Same if we type anything to the is part, or to the, well, in our case, event. Gvent, yeah, it's not a boundary of the word. Or let's say there's a space. Well, we could use two spaces, but what this now tells us is that there now needs to be two spaces specifically between these words, right? The space is here, the space is here. So we can have something like a space with a question mark here, and now it will only require one space, or a space with a question mark here, but now this means we can not have a space here at all, right? And what I'm trying to get here at, this thing says that we can have anything typed in here. This part is gonna match on everything that goes between my and event, and the pattern still applies because it says find the literal words, the name of my, then a space, then anything here, any character repeated any times, maybe not a single time at all. Event is, and then it follows with event is, and that's still matching our pattern. There's also a quantifier for a specific number of repetitions, which is this curly braces, and there you can either type in the exact number of how many times this thing should repeat. And as I said, this can be a group. So repeat Paul 3 times specifically, repeat Paul 2 times specifically, repeat once. There can also be like repeat at least 2 times, 2 comma, and not a number after that, means repeat only 2 times. Repeat at least 2 times, but indefinite, the maximum number is whatever. It can be Paul, Paul. Gosh, I love myself. Paul, right? So this means 2 or more times, like 3 or more times. And then you can have something like from 2 to 3 times. So it's only gonna match Paul from 2 to 3 times, but not the 4th time. And if I remember correctly, no, I guess not. There's no such thing as 2 times max, although I remember there used to be. So maybe it's somewhere in there. So exactly 3 or more of A, between 3 and 6 of A. I guess if you want between 0 and 2, that's how you just type it, from 0 to 2, or between 1 and 2. You have to set the lower bound there. Yeah, so this is this for now. Then there's also a way to match all characters in a set, so everything from A to Z. And here, the dash is literally a dash, right? It's the character hyphen, literally. But when you use these square brackets, it now also has a special meaning. If you're looking for a dash on itself, yeah, it's still gonna match. But if you put something like 1 dash 2, now it's not gonna match the dash. It's gonna match all the numbers between 1 and 2, all the numbers between 1 and 3, all numbers between 1 and 5, right? 2 matches, 0 doesn't, 2 matches, 1 matches, 5 matches, like all numbers from 0 to 5. And again, we can use a modifier to match every instance where there's at least one number, but it can be more numbers, between 0 and 5. And it gives us 2021, 05, 20. But if we now have the year 2026, the 6 itself is not now a part of the match. because, well, it's not included in our range here. And you can have multiple ranges here as well. So you can have a range from 0 to 5, then from letters A to Z. And if you're not using the case insensitive, you can also include a range from like lowercase, uppercase A to Z. So this now means any character from this set repeated once or more times. This is what we are searching for, but without the numbers 6 to 9, right? So this is now matching on everything that may have numbers within, but not the number 6, not the number 7, because this now splits our matches into separate matches, because this is now not a part of our ongoing match, right? So this is another way of how you can, specify. You can specify like letters literally 1, 2, 3, 4, 5, and 0. But 0 is like the first one, 0, 1, 2, 3, 4, 5. Or you can use 0 dash 5 or hyphen 5 to specify the whole set already. And the sets are actually they are obeying. So you cannot specify, for instance, something like A to Z, because this is not a proper range. Because, well, if you remember from one of my previous tutorials, if you look at the do we have the character map? Yeah, in every system there's a character map, or you can Google for Unicode. Each letter has a code in the system, so they in a way are ordered. Each one of them has a character. This is a hexadecimal value, but they are also, well, they correspond to normal values, and that's what you feed to the character formula, to the character function in Coda, if you want to get a specific character. So this is all your characters, all Unicode characters, or most of the Unicode characters ordered. And this is pretty much how they appear in the encoding tables. So first there's these characters, then there's 0 to 9, then there's uppercase Latin characters, then there's lowercase Latin characters, then everything else goes. So you can find Cyrillic here, down there Greek letters, some other alphabets, etc. Then in the very end there is going to be some emoji, but you need to look at a more extended character map. Like, again, you can search for Unicode map, and there's gonna be, the whole Unicode table. You can scroll through it. So this is the order of characters, of how they are encoded internally in your computer. And you can only use these ranges when you put a character with a lower code, with a lower position first. And this is gonna match everything from A uppercase to Z lowercase, which means all this here. Then the square brackets, the forward slash, the closing square bracket, this character, the backtick, and only then the lowercase letters. So it's gonna match. If we have this, it's gonna match this. It's gonna include that in the range as well. That's something to know. But if you type it like this, specifically A to Z, then it's gonna take two separate ranges and not include whatever is between these ranges, so not include these square brackets. So that's something to know about as well. Yeah, so this is the ranges. And if you want to say, okay, match everything that's not these characters, you put a, Shift 6, right? So the I don't know how you call this character. Does this character have a name? This one, circumflex, circumflex accent. On the start of your sequence. So if it's the first character of your sequence, it tells match everything that's not in this sequence. So match everything that's not A, B, C. See, it ignored the letters A, C, like match everything that's not numbers from 6 to 9. So it matched everything but the number 6, but the number 7. So this is, and if you want to specifically match the, well, the circumflex, you have to add this backslash to it. And now this means this character exactly, and then everything that's from 6 to 9, right? So, or you put a circumflex, it means not this character exactly, and not anything that's 6 to 9. So, or you can put a backwards. So right now it's all the numbers from 0 to 9. But if you put a backwards slash before the hyphen, it now becomes literally 0, literally a hyphen, or literally a 9. So it matches, it now stopped matching on everything between 0 and 9, but now it's matching literally on the slash. Because this character, the back slash before any character that's, well, a character, except the new line, those few predefined ones, the space, etc., means take this dash literally, take this dot literally, take this square bracket literally, because otherwise it would, well, treat it as a part of your syntax of the regular expression. So that's why you're using this escape character, the backslash there. So this is the selector of like anything from P, A, and U. And if we use the case insensitive, this means that lower or uppercase match, find a string containing one character that's either of these three. Another way to do this, you can also have an or. P or A or U. So this character means an alternative, everything that's to the left of it. So it's like an if or switch if. P or A or U. And of course, if I'm showing this using like a single letter thing, or this is a sequence, P or a U or L. So here's P, here's a U, here's L, here's another L, here's another L. If I say L or two L's, it's gonna first match. It tries to find the first match or the second match or the third match. If I flipped them together, so first try to look for two L's, then just one L in a row. Then it would go from left to right. It found P, it found AU. It didn't find P, it didn't find AU, but it found LL. It found another LL, it found another LL, and now it found them in pairs first. And only if it couldn't find two LLs anymore, it tested for the fourth piece of our alternative. So it tests them in order as well. And of course, I'm showing this on simple examples, but you should always know that if you put a brackets in here, you can go for a much longer expression. So you can test for everything that's 1 to 9. Actually, you can even not use the brackets here, but everything that's 1 to 9 or 0 to 9 multiplied multiple times. So you can put a whole sub-expression in here. And if you want to group some tests, so it's either P or that, or it's LL. Oh. This thing now takes the or of this whole expression, of this whole group, or this. So it's gonna match on this or on this. So you can, yeah, also combine these things, and don't forget that you have brackets. How you can group pieces of your. But again, it's really hard to explain these things on a basic level, because that's what most tutorials do. They take some simple, trivial examples, but then in the real world, that's not what you are doing normally. I'm sorry, one sec. Okay. So this is like the basics for now. Oh, also there's a few more things. There's a special character. So see that it's not in the brackets now, right? So it's not the negate the number of characters that you are using here. It's outside the square brackets. This means the start of the line. So now, right now we are in the multi-line mode, which means it matches every start of the line. So this way, for instance, you may test for all the lines that start with three only match strings where these three things appear at the start of the line. So if I put them here, this is now not a match. If I remove this condition that it should be a start of the line before these three characters, now it matches it here. But if I add this here, this means only match where there's start of the line and then there's these three characters coming. Or start of the line and then there's the poll name used, and only in the start of the line. A similar thing there is for end of the line, it's the dollar character. So only match substrings where you can see these letters, literally the sequence of P, A, U, and L, and there's an end of the line. So speaking of this thing, it's only gonna find this one because there's nothing else after it's in the end of the line. If I put a space in here, now it's not matching anymore because it's not the end of the line. So word awesome, we match it if it's in the end of the line. If we put something else before the end of the line, it's not gonna match anymore. But we can check, for instance, add an exclamation mark, add a question mark to that. This means that this exclamation mark is now optional because the question mark is a special thing, right? A quantifier which says match it if it's there. If it's not there, it's optional. So if it's now a question mark, if it's now an exclamation mark, it still matches. If it's anything else than an exclamation mark, it doesn't match, right? If it's two exclamation marks, it doesn't match either. But if we set now a asterisk, now it's gonna match as many or neither, or as many exclamation marks as we need. So this is how you combine things together. And if you want to have an alternative, is awesome or great, you cannot do it like this because this thing now gonna match is awesome or this. But we want to, for instance, to match against, there's a word is, and then there's a space, then there's either awesome or great, and then there's like 0 or more exclamation marks and the line end. So this is where you use the brackets. So now it matches against is awesome, but also matches against is great, right? So this is now this or only works this part or this part within the brackets, right? Yeah. What else? So yeah, these are called anchors. Start of the string, end of the string, and yeah, word boundary, non-word boundary. I talked about them earlier. I'm not using word boundary characters, so I guess it's not as important to know. Yeah, here you have all the reference that you need, so it helps you. And here it gives you the explanation of regular expression, right? So characters of the range, any character, alternatives, spaces, word, digit. Oh yeah, I forgot that I'm very often testing, so this is equivalent to 0 to 9, and the uppercase, the D, is equivalent non-0 to 9, so everything that's not a digit, right? I'm using that very often. So if, let's say, you have a table and you have some model names, and you want to match specifically, find these model names, you know that it's two letters, then there's a dash, then there's 4 digits. How you'd match that? You'd match something like A to Z, uppercase, specifically 2 things, then there's a dash, and then there's specifically 4 digits. So this is now, you should now understand what I just typed. So this is something in a range from uppercase A to uppercase Z repeated exactly 2 times. Then there's literally a dash. We don't need to use a slash, a backward slash here because it's not in the brackets. So it's already a literal dash, matches the character dash literally. And then the digit is repeated 4 times. So not 3 times, not 5 times. It's only gonna match, like, let's say we only want to match where this digit appears. So this is the only thing that's on our line. So we test, there's a start line, then there's this whole content, and then there's the end line, right? So now, if we put anything else before the end line, it doesn't match anymore. If there's not 4 digits but 3 digits, it doesn't match anymore. If one of these things is not a digit, it doesn't match anymore. It's not, we described our pattern very strictly, right? So this is the only thing that needs to be here on this line. Or here, if it's a lower case, I guess here we, yeah, case insensitive, we turned it on. So it's a lower case, it's not in the range anymore, right? It's a number, there's 1 letter or 3 letters, it doesn't match that. So, do you understand? Yeah, you do understand, finally. Great, so this is like something that you can already go and use. Yeah, I told we don't need breaks. I'll probably catch some breath, have some water. I'm not like setting up any timer, any down timer, but let's say let's meet back at 6 p.m. and like it's not gonna be 4. Let's say it's like 18:08. I'm gonna start talking again. So feel free to take a break. I'm gonna take a break myself. Oh, and if you have any pieces of text, any interesting pieces of content, well, text content that you'd like uh, to see me test the regular expressions on or write regular expressions for, feel free to type them into the chat. I'll take them as a learning example. Otherwise, I'll just continue with this piece of, well, the Typeform. This is what comes if Zapier takes the whole Typeform and inserts it into code. It comes in this way. If you don't take every question one by one, but if you take one big chunk of the whole submission, that's what I'm doing. By the way, there is a similar thing in Word, Excel. They don't use the regular expressions, this kind of syntax. They have a different kind of syntax. That's for your information. You can find it by using like Word. Um, how do they call wildcards? So there's a bit of a different syntax. I don't know. I'm just clicking on the first. Yeah, so they have like in regular expressions it's dot, it's any character. In Word it's a question mark. Just this is not a quantifier, this is like any number of characters. So this is pretty much similar. One of these characters, yeah, the range. So they all basically follow some similar designs. So they were designed I guess, in mind with some similar principles. Yeah, so these quantifiers are also present in Word. The classes, like the new line, we have the slash and, but in Word we have like circumflex p. It's a paragraph, right, or something. Yeah, two paragraph breaks. Well, yeah, you have this capability, so it's like as I said, many people fear it because it's like, what is that? We don't understand that. Even though once you get it and once you start applying it to your everyday data manipulation needs, you very quickly start to love it, to love how easy it is to describe the pattern. You just need to remember these pieces, how you compose the pattern, what each of these things means, and tools like regex 101 help a lot because there's an explanation here in the right. So position at start of a line, then we match this, that, and then what the flags mean. Of course, if we now select single line instead of a multi-line, it's not gonna match because the beginning of the line is here and the end of the line is here, right? So it's now, but if it's the only thing that we had, let's say we delete this and we delete everything from here to the end, right? So this is now, it's the only thing that's in our whole text. Yeah, Virginie, last time tried using regular expression at Coda to extract some info from a doc URL and ended up using split. Yeah, but I guess right now you can. Let's maybe duplicate this tab. Let's take actually some URL and let's try and dissect it. And it's gonna be a very good example of what to do with how you work with groups. So let's take this big URL here, right? This is our test string because yeah, often you will not be working with, well, you will be working with this, but let's say you want to work with this and you want to extract the doc ID, which is this thing. You want to extract the section or page ID, the view or table ID, and maybe the row ID, the column ID, and if it's a modal or not. So it's a good example, actually. Thank you for that. It's a good example to work with. And it's a good example to explain one more thing, which is like it's not on the basics of the regular expressions. It's the thing that I often overlooked myself, because in the beginning you don't really need it, but when you start, when you know about it, you start applying it everywhere. So let's say I want to match on the document ID, and I know that the document ID always starts with the underscore D, and then what goes next? There go 10 characters, but the document ID can also have, so right here it's just the one something something, but if I look into any of the docs, maybe let's take a roadmap. No, it doesn't have a slash. Let's maybe look into some more docs. Because some docs have dashes in here, so they don't necessarily have only the numbers and letters. Let's maybe oh, here for instance, there is an underscore here. I don't know if they can have dashes, but they have an underscore here. Maybe there is no dashes. I don't know. Let's try a few more. Docs, no. Okay, let's assume that and we opened quite a few docs now. Let's assume that it's only the word character, which is one of these, 0 to 9. They can have dashes, you say. Yeah, okay. So this means that we need to include our dashes. So it's gonna be 10 either word characters or a dash. Exactly 10 times. So this is now like the whole regular expression matches literally the underscore, the D, and then the doc URL, right? So it's our match. We can do this. We can put. So now it's time to learn about groups. So I said it's not. We want to extract specifically this part. I said that the brackets is not just a group, it also has a special meaning. And the special meaning is that things that we find in brackets, like the first instance, because if we now have this multiple times, right? Let's say we have one doc URL, and then we have like another doc URL here, and let's say it's something else. It's gonna, this thing is a capturing group. Capturing group means that in our output, we have the whole match, but we also have separately that piece that's within the brackets, round brackets. So we have this as we can extract it from a bigger match. We can extract pieces of that bigger match as groups specifically. But the way it works, it only gives you the last time, the last value of the group. So this group appears twice. This is like, let's test it in, yeah, so this group appeared twice. It doesn't highlight it in here. Let's maybe paste it a few more times. Yeah, it doesn't highlight it in here. It only highlights the last inclusion of that group. So the way it works is if a group repeats, then only the last instance of that repetition is included. Oh well, this means 0 or 1, but 1 if possible, and if you add another question mark to that, it's gonna be 0 or 1, but 0 if possible, right? So this is also something for you to remember. So added question mark means as fewer times as possible, not as many times as possible. So if you have like 1 or more times, but as fewer times as possible, that's gonna like not include the second match. It's gonna say, okay, it's already a match if it's at least one time. It's found at least one time. But if we say at least one time, but then there's a slash after that, and we need to escape the slash, right? Because it's like a special character that it says it needs to be escaped with a slash. Then it's gonna, well, the just one time doesn't work because there's no slash after it. But so it's gonna test for, okay, let's say 2 times, or like more than 1, 2 times at least, and 3 times, 4 times, so until a match is found. So that's going back to that. So yeah, we have this capturing group, and that's how we extract, like this is the piece that says this. Then we have, let's test for the whole URL, right? So we have, in the beginning, we have HTTPS literally // but we need to escape them with a backward slash. So we have http // then coda.io, and the dot is not just the dot. You have to escape the dot, because if you have a word Codacio or whatever, it's gonna match because the dot is any character. It's not a dot. You only need to escape the dot with a backward slash, because only then it's gonna only match the dot. Then you have /d /. Then you have whatever for actually the URL can look just like this, right? So it can look like this, or it can have whatever name. We don't care about what happens here as long as we find _d here. And in a way, we know that _d will not happen anywhere in the document anymore. But let's say that just for testing reason, we may see another _d in the end. So what happens now? It's gonna match as much as possible before it finds this d. So it's not gonna stop here. It's gonna try match more until it finds the d, and it's the last d that it finds. And that's where you may want to add that lazy matching, so that the regular expression matching stops when it finds the first d. So it's as fewer times as possible, as fewer characters as possible before the next _d. So this is the difference between eager and lazy matching, or not eager, but there's another word for that, right? So it's where is it? Greedy matching. Yeah, greedy and lazy matching. Oh, you can say eager and lazy matching is the same thing. But we know that the _d is not gonna appear anywhere in the docs, so you are pretty much okay without using that thing. Or another thing that you can use is you can use a group and say everything that's not and how do you say not in a group? Okay, this is like, we didn't cover that yet, because this is like not any of these characters, but we pretty much want to match the d anywhere, right? But yeah, we know for sure that there is not gonna be an underscore anywhere in the name, because everything's gonna be replaced with dashes. So in a way, we could test a doc name for any word character, but also a dash repeated as many times as possible. And if we include that in a match, this is gonna give us our doc name portion. So this is gonna now extract our doc name portion, then another match is gonna extract us our, again, word character or a dash exactly 10 times. This is our doc ID, the second group, right? Then we have our slash, then we have our, again, it's optional. So this thing is the doc ID, the page ID. We also have pretty much the same qualifier here. It's our name, but stop whenever we see _s, and then we have another group of, well, we know that the next things that go after SU, or it's actually a part of the group SU, and then we have 3 characters, and we don't have to be specific that it's just word characters. We actually here, we can also not be specific. We know that any character, we can have any characters here 10 times. It's our doc ID, because we know that it goes after the D, right? SU, so this is our page ID. Then we may have a totally optional, we have our thing here. We have, again, and this, by the way, we can also replace, we can say any letter. So anything can go in there. So it's anything that's repeated, but just stop when you see /d, or, well, stop when you see /d, or go back and find slash first match. So how it works right now, if I leave it like that, it's actually not a good idea to leave it like that, because as you can see, 245 steps. Why? Because first it tries to match everything, so to the end of the doc, and only then it tries to see whether this now ends with _d. Now it gives back one character, gives back one character, gives back one character, gives back one character, and only then, somewhere in the very end of this evaluation, after 200 steps, it finds, I need to go to 300 steps, it finds that, okay, now there is a match. So it went always, first it matched everything, then it went all the way back until it actually found this _d in the end. Now we are talking about performance of the regular expressions. So if you were using, let's close this. If you were using lazy matching, you can see that it's fewer steps. It's 102 steps. And why and how is that? Because now it goes to this, and now instead of going back from matching everything and going back, like releasing, giving back character after character, it's now taking one character and checking whether the next one is /d, is _d. So instead of giving back, it gets one more character and then checks, gets one more character and then checks, backtracks, checks one more character and then checks until it finally finds this /d. But even a more performant way to do this is to perhaps check for everything that's, well, we know that that underscore is not gonna appear here. So we check for everything that's not an underscore specifically, multiply it as many times as we need. And then check for the rest of the expressions, _d. So what this does, it goes, instead of going forward, checking, looking ahead whether there's an underscore, and then adding one character, and then adding one character, what it does, it simply takes characters, so the steps, as you can see, this thing is like a single step. It just takes everything that's not a dash, so it stops, it matches the biggest piece that doesn't have dashes in it, and it's super performant to find the next dash. It's like, it doesn't have to look ahead and then back and then ahead and then back. You get what I mean? So it's even fewer steps, it's even easier on the performance to write it like that. So that's now, well, maybe the pro level, when you know that there's multiple ways to describe your pattern, you can find the one that's the most performant once you know these things, how it works actually under the hood, how it matches. And again, this debugger works if you select the PHP variant of the regular expression. The JavaScript doesn't have this debugger here, so use the JavaScript language to test these things that will work in Coda, but use the PHP flavor when you want to see, like, to educate yourself about how this matches step by step, or to debug your expression. So it's, again, one a piece of knowledge for you. But what if okay, here would be a good idea. Yeah, I'm not gonna now dissect the whole URL. Let's just focus on this part, because I'm thinking of what to talk next. So see how I'm typing /d, then I have our 10 characters, right? So it's our doc ID. I can extract the doc ID. The problem with Coda, though, is that I don't know, if I remember correctly, so first thing about Coda, you have the regex replace, regex match, so whether the text matches, and I guess the regex match, actually, it takes so here you find a match, right? There is a match. We don't have to type in the beginning and the end of the character. So let's say here's the text, and let's say here's our regular expression, the one that we just typed. I think Oh, well, there is a match. Yeah, there is a match, right? There is a match. Yeah, it tests not the whole string, but it tests that there is a match somewhere in the string. So if you want to test whether the whole string matches this, of course, you need to add these things, the start and the end of the text. So if this whole text is only this piece, only then it's a match. But if there's anything before it and after it, then it's not, right? So you have to remember to add these things in Coda as well. So now it's false, and it's now gonna only be true if this part is the only thing. So if there's anything else, nah. If there's anything else before, nah. If there's anything else after, nah. It's only true if this is the whole text matching. So these two characters, remember about them, the start of the text and the end of the text. Okay. What if, no, back to Coda. You have regex match. You have regex replace. So you can, for instance, take this text, take this part, and replace it with the text redacted, right? You can replace it with just the text, but it will replace the whole regex. See how it replaced the underscore D as well. So one option that you have, if you specifically know that it's underscore D, you just type it in here. But what if you want to replace, like, not just the D? Let's say we go into the replacement substitution mode here. We replace this with hidden. And we don't want just to replace the doc ID. We want to replace the section ID, and we want to replace the table ID, and we maybe want to replace the column ID. So we want to match on all of these. So we know that this starts with an underscore. Then we have either of the letters, or actually we have either of the letters like D, S, T. Oh, and now you can see that now this matches all the 10 letters. It now matches all the 10 letters after. It doesn't tell apart that this is now the end of this thing, right? What you can do, you can like say 5 to 10, but it's gonna be like still 10. If it can match 10 letters, then it's gonna match 10 letters, right? So this now is not right. You can add things like, say, everything that's not a forward slash and that's not a and that's not this thing, and it's 5 to 10 letters, or no, 3 to 10 letters, right? So now we kind of have something that matches what we are looking for. It's suboptimal because, well, we have underscores here as well. So what may happen is that, well, normally it will consume this thing, but if we have as here, no, it will consume this thing, but still, I wouldn't rely on that. What I would do, I would just make it either, well, I would just specify that, okay, this is our group. It's D and 10 letters, or S and 3 letters, or 4 letters, or yeah, see how with my previous regex I made this mistake. I assume it was 3 to 10, but now if this was an underscore, I wouldn't be so sure that it would be captured properly. So yeah, let's rewrite this thing. So it's underscore, then it's D or S or T or C because of column ID. No, column ID has a different pattern. So that would be like column ID would be C dash and then 10 characters of the column ID. So this is like another variant of an expression. But this is DST, and then, oh, well, it's D and 10 characters, or it's T or T or S. It's, yeah, or I can write it like T or S, right? T or S, U, and then 3 characters after that. And one of the things here is that, okay, we are captured, so, well, the way how groups will be captured, it's like, these are now separate matches, right? And we replace all these matches with the hidden word. We cannot replace separate groups, we replace the whole match. But let's say we don't want to, first we are not interested in these groups at all. Now it's okay to just leave them be. But if we are not interested in these groups at all, what you can do is make it a non-capturing group by specifying by adding, prepending a question mark and a colon. This means we now have something that behaves like a group, but we don't extract it specifically. We don't care about this data. So we don't care if we just have this D here, yeah, it's gonna extract it in a group. In Coda, we will not probably get a hold of it at all. But if we don't want to capture it, we may add this to the beginning of the group to say, okay, this, let it behave like brackets, but we are not interested, we don't want to extract this piece here. But in this case, we actually do want to extract this piece, because what we want to do, we want to preserve this in our replacement. So we are actually interested in this underscore D, and we are actually interested in this T and S, and see how this is now group 2, because it's a different group in our regular expression. So we probably need to rewrite our regular expression. And now we can use, I don't remember if it's, yeah, in JavaScript and perhaps Coda, it's $, and here's how we can actually refer to whatever was matched. The whole expression is a $and 0. It should work. Doesn't work. $0. No, doesn't work like that. Let's go back into Coda, because I think it should work, right? So $0, no, doesn't match. If we add this to a group, no. A %0, no. $1. Oh yeah, $0 does not give us the whole match. Although I remember that there was there had to be the whole match. Was it? So the $, it definitely was the whole match. Maybe I'm mixing it up, because maybe in, yeah, maybe in the entire pattern background. Yeah, in PHP maybe this works. In JavaScript, so this is the first capturing group, the second capturing group. I kind of remember there was a way to insert the whole match. Maybe I'm mistaken. Let's Google that. So regex replace full match. Yeah, in a way I have a feeling that maybe in JavaScript they disable this possibility. Maybe it's the way how it works. So if I find a way to insert the whole the whole match, I'll let you know, but I don't know what's the practical reason for it. But okay, I extracted the prepending text in a group, in the first group, and now I can preserve, I can insert it here. So before the text hidden, or to just showcase that I can use the replacement pieces if I put them in capturing groups. I can use them as a part of replacement string. So it captures this value and I can insert it along with the replacement. And same for the second group, the third group, the fourth group. And if I'm not interested in this group, if I turn it off, then of course the first one's gonna be this one. The group one is gonna be this one and not the other one, right? So yeah, this is the capturing groups. Let's go back to the let's look at another use case. It's a hidden formula and it's the most powerful of all. It's regex extract. It's a hidden formula. I think they haven't finalized yet with how it works, but it gives you this matches that you see here on the right. So there is regex replace, right? So it finds a substring by a pattern, replaces it with something, perhaps a part of that pattern. There's the regex match, and then there's the regex extract. Extract pieces of data that are matching this pattern. And the reason why it's hidden, I guess this is because these flags, they are still asking you to insert the flags just like you see here, GS, GE, Unicode S. So what I'm doing often here, I'm just typing GIUS, GIUS, which means global search, find all the matches. So if I have, for instance, here a regular expression that matches just any character, or matches a /, if I don't use the G, it just returns one text value, right? The first match. If I use the G, it's gonna return now a list of text values. So it's now a list of text values, so all matches, right? So if our, let's say I want to have all A to Z, all words, well, everything that's A to Z, right? E gives us case insensitive matching, U gives us Unicode matching. So if I try to match on like Russian characters, well, you can actually, yeah, just use, exclude that from here. And S means treat it as a single line, doesn't matter in this case particularly, but when you are working with, like here, you want to separate these things, you kind of want to use the single line character so that you can split by like 3 new lines, for instance, and get your yeah, split by these things and match this without knowing that, without thinking that, okay, it's already split into lines and you're looking at each line in isolation. So yeah, where's our coda? Yeah. So, and if you don't use G, it's just one text value, the first match. If you use G, it gives you the list of text values. And actually, doesn't matter if you use capturing groups here, non-capturing groups, it's not gonna give you that information. So there's no way for you to extract that group information in Coda. You can extract that if you're programming with JavaScript, you can extract them here and, well, export these things, but you cannot really, so for Coda specifically, the knowledge of this versus this does not really apply if you're using regex extract. It does apply if you are using regex replace. So in a way, this is important to know. So if there's a group that you don't want to extract into the $1, $2, $3 variable for your replacement, then you can mark it as a non-capturing group by, yeah, saying that, adding this. Okay, I feel like I'm starting to lose the cohesiveness of my speech. Virgin, are you still with me? And is everything still clear? There's just one more thing that I want to show. Because again, you're not using it in the beginning, and I wasn't using it until I learned about this, and it just gave me so much possibility and so many more things that I can do now with regular expressions. It's the look aheads and the look behinds. So let's again match for our D and then 10 letters. So the whole match is now this, right? So let's say we want to just extract the document ID, and we don't care about this thing. If we had groups, we could put this in a group, and this would give us the group, right? The first group. Unfortunately, in Coda, if we try to take this D and then make a group and then say 10 characters that go after the D, it's still gonna return us the whole match, right? So of course we can then go and like take the middle from the start and 10 characters starting from the third one. So yeah, you in a way you can hack around it, but let's do everything with regular expressions, right? So the D that we specified here is a part of our match, is a part of our pattern. What if there were a way to say, okay, let's match 10 characters that go after the underscore D, but the underscore D is not part of the pattern. We don't need to extract that. But we are interested in 10 letters that go after the underscore D. And for that, my people, we can use a negative, we can use a look behind. It's a question mark equals. So we put this before our string, and actually we don't need a group here. This means now positive look ahead, positive look behind. It needs to be this, right? The less or equals. I mean back. Right? It looks like an arrow back. What this means now, the look behind, is that match 10 characters if and only if characters before it are this. So within this group. But not make that a part of our match. And this means we can now include this multiple times, and it's not going to be a part of our match. But if we don't include this, it's not going to match this piece, right? Because there's no underscore D before it, or underscore S, or underscore X, right? So this is how we extract if we are not interested in submission. So, okay, yeah, we can hack our way around it. But why if you have this capability of looking behind? You have a negative look behind. Match these 10 characters if and only if what's before it is slash, is not a slash. So an equal sign becomes an exclamation point. So it's negative look behind. So only match 10 characters if it's not the slash before it. So it's matched it here, matched it here. Well, only match a character, let's say, if it's not a slash before it. Now it's more obvious here, yeah? It matches everything in here, matches everything, but not this character before, because there's a slash before it. Not this character itself, because there's a slash before it. Not this character, not this character, not this character. I guess you get a point. But if you put an equal sign, this means only match, give us the characters that are prepended by this, but don't make that a part of your search string. And the thing here, the interesting thing here, is that if you now type your, let's say you want to capture the D, and now you want to capture your 10 symbols, you still can have that negative look behind, and it's still gonna match you the whole pattern. So in a way, how it works, match the underscore D and then only match these 10 letters if there is a D before it. So it doesn't, sorry. So this thing does not eat up characters. This is more like a check for it. So part of an expression eats our characters. I don't know, I don't have a nice example to show it to you, but let's just say that okay, let me think maybe of a good example here. I know we only have like 13 minutes left. I want to go and have something to eat because I have another live stream in an hour where I'll sit down and build a dock. So I want to get this over with. Oh, well, okay, I'm gonna show it not with the look ahead, but with the look behind. Not with the look behind, but with the look ahead. So there's the look behind, and there's also a look ahead. Like, match 10 characters only if what's coming next is a forward slash, right? So what it does, it only matches the characters, the 10 characters. So it tries to match, like, first it tries to match it here. I guess you can see that there's a lot of steps here. And if you go into the debugger, it's gonna try test for these 10 characters, but there is not a match before it. Try test for these characters, try to test for these characters, these, until it finds the match somewhere after it. So it's not like it's just for the learning. It's just for the learning reasons. Now it's not like a good way to do it. It's not the performant one, but eventually it finds the 10 characters that actually that you see, then a slash after it. But then if you want to test for the rest of the continue writing your expression, this does not eat up this slash. You can type this slash here, D slash here, like team, or well, whatever your name, document ID, 10 letters after your document ID, and so on and so on. This thing here, the look ahead, just makes sure that there's this thing after this. But it doesn't eat up into it. I can have the whole look ahead typed out in here. So take the 10 characters before slash D slash, right? But I can still take this slash D slash as a part. There's no reason to do that, right? You don't need that look ahead, actually. But just in case you want to do this, maybe there's some elaborate scenario. I cannot think of one at the moment, but there may be. I remember using look aheads, actually, and then having the rest of the expressions somewhere. Maybe you want to match for it or whatever. Again, it's not wise to do it here, but just in case, you can do it. You can have this expression of what to look ahead. It doesn't consume these letters, so it's not like we just skipped them because they are here and then we team. No, it won't work, because this thing does not eat up into it. It just checks ahead, but it doesn't eat up into the next characters. So you have to, here you assume that you are just past these 10 letters. Yeah, so this is your positive look ahead, negative look ahead, positive look behind, and this thing, so this thing applies basically to what comes next. So if it's a letter T that's prepended by this, you put it like this. So, well, and if you are interested in 10 characters that go after this, then you put it to the, well, first the look behind and then the 10 characters. And you can also use a look ahead. So find 10 characters. So first find a place where the next sequence is a document ID. So find a place where the next, so it's gonna what it's gonna do, it's gonna, there's nothing in here, so it's just gonna find, yeah, it's just gonna find the place where it finds the underscore D, but then without eating into this D, the cursor is here. It just found a place that the next two spaces, the next two positions are D, but the cursor is here. Take the 10 characters after it, or, well, if we want this whole thing, take 12 characters after the cursor. So this is how you can, another way of how you can use the positive look behind it. That's the illustration of how it doesn't eat into the actual match, that doesn't move the cursor forward. Okay, look ahead, look behind, something that I didn't use for a while, but now I'm using it and I really like it. So what I should finish with, so meta sequences, okay, there's some sub patterns, never using it, never using Unicode classes really, unless I need something like super with Unicode matching, like with emojis maybe, but no, it's not something that you will do in your Coda practice. And when you actually have a need to do this, I guess you'll know. By that time, you'll be a master of regular expressions and you will learn how to look it up. So it's not something that I need to talk about now. Yeah, lazy possessive quantifier. What is the possessive quantifier? So never actually, maybe once in my whole career, I found myself using it. So to be completely honest, I'm not comfortable explaining it because I don't understand it as much. Maybe I used it once, the possessive quantifier. I guess it plays along with all those zero or all those optional matches that come after it. It may affect the result, but I'm not super sure. Groups. So yeah, doesn't allow backtracking. There's a lot about this backtracking thing, which I don't. Inline modifiers. Okay, JavaScript has that. You can only have a portion of regular expression, be case insensitive. Okay, this is new for me, and that's why, if you wish, you can learn about it yourself. It's not like this will enhance your experience with regular expressions too much. So the things that I explained here is something that you will have to you will deal with on a daily basis. These things you can learn on your own pace. Like, I don't feel like I missed something important here, right? So I don't I know that, I don't know if JavaScript has that. So there are also not just group 1, group 2, there are also named groups. So let's say there is the doc ID and we can make it. So we want to make it a named group. Yeah, this is the group doc ID. Again, doesn't make much use for it in Coda, because in Coda you cannot really extract groups. So substitution, well, it works. So you have a doc ID. Does it work? It doesn't. Can you? Yeah. Oh, well, you have this named thing. Let's test this in Coda. Regex replace. And while we are still on the stream, there's like 5 minutes left. Anyone in the chat, Virginie or anyone, is everything clear? Or if not, feel free to ask. If something's like not entirely clear, if you're interested in some specific use case, please do let me know. I'll be happy to talk about it. So I have this group and I want to make a replacement. Will this work? No, this does not work. This does not replace it with the doc ID. So one it is to take the match and put the match where, so here's like doc ID and our match inserted here, the first group and the rest. I guess if you just want everything, you can, yeah, put everything in a group, and this is how you get the $1. But I do remember that there was like the whole match. The 0 used to work, or the dollar, no. Well, to hell with it. Okay, this is pretty much what I wanted to talk about. Of course, you may want to make your regular expressions longer. You may want to extract more pieces at a time. It's always, well, when you have the ropes, you have the understanding of how to do it. You can combine regular expressions and the simple split. You can, well, break it down into pieces, break down the task into pieces. So like like here, yeah, where is that Ian's doc? This. You can first, for instance, we have this string here, right? So let's just use this doc, right? Raw data. You can have this thing and regex extract raw data and just extract everything that's starts, everything that's between the three, everything that's between the three things, and then as fewer things as possible, but then there's 3 new lines. And this and we need the global flag and the single line. And this is now, this is how we got, let's say, for the brevity bullet list. Okay, it doesn't look very nice. So we extracted everything that starts with this, as fewer things as possible, and then there's the, well, the 3 new lines. And oh yeah, because there are new lines within each of these things. So yeah, so what's the count here? 16. Yeah, so the 16 things. And I want to take these pieces of text. Why is the bulleted list not working here? So this is our list. Yeah. Formula map. Current value. Again, let's replace all new lines, including multiple new lines, with just spaces. And trim the end result. And now we have our bulleted list of these things. So what we did, we split, we separated, we extracted all matches that start with 3 pound symbols, and then match as little characters as possible until the next time we encounter 3 new lines. Because if we don't do this, if we do it in a greedy way, it's gonna match up everything until the very end, until the very last time it finds this. So we need to do the eager matching. Also, we just, I think on presenting performing needs, we lost that match because there's no 3 new lines after that. So we can have something like a group here. It's this or it's the very end. Got it. Now it matches that ends in 3 new lines, or it ends, just ends. So match everything up until the end. And this is how we extracted out of this piece of data. We extracted our question answers. Well, we formatted them in some way that's easier for us to digest. So in a way, this is, well, like, there's also 2 spaces here, so maybe some replacement of multiple lines. We don't need to make a group here, or multiple spaces, so where 2 or more spaces, replace that with a single space. And well, this is already much nicer to look at than this, right? So of course I'm doing something different with it, but just for your for the display purposes, this is one of the ways how you can use regular expressions once you understand what's happening. So what looked intimidating, and I know that this like string of characters can actually look very intimidating, but once you know how to read it, once you know what this whole thing means, and hopefully it's clear, you can now go and play around with it yourself, and hopefully it's an aha moment for you and you already see how you can use it very efficiently for many of scenarios where you previously didn't know how to approach. Okay, that is gonna be all for this lecture from me. Once again, finishing with saying thank you to all my patrons. I'm gonna go have something to eat. I prepared myself a dinner and it's been 2 hours. I think it's cold by now, or maybe not because I put it in a blanket. I'm gonna see you in an hour. I'm probably gonna be very tired, so I'll talk less. Maybe it's a bad idea actually that I put the cross dog best practices tomorrow after the dog build and not before the dog build. But let's see. Let's see how it goes. So yeah, see you in an hour on a different YouTube link. Cheers.